morning, everyone. Uh, okay, so we are ready now for this lecture. Uh, I'd like to welcome all of you to my class. We are
Thank
going.
you, sir.
We're
Good
going.
morning, sir.
Good morning, everyone. We are going to start with the chapter number 3. And before we begin, uh, I'd like to make a few rules clear. Please keep your mic muted at all times. Okay, and you can keep your videos off to save your data, no problem with that. Okay, if you have a question, if you don't understand something that I'm explaining, then you could type that question in the chat. Okay, then we will take your questions. All right, after you type it in the chat, I will read it and we'll take your questions. Okay, so i'm going to I'm going to share my screen so you will be able to see a board. Okay, and we're going to use that right now. When you have something on the screen, uh, please note it as well. Okay, so you have to do a lot of things together. You have to understand what I'm trying to explain, you have to read it, okay, and you have to note it down as well. Okay, uh, through the lecture I will ask you some questions. You can answer those questions using the chat, right? Don't worry whether your answer is right or wrong, no problem. Nobody's going to see it except me. All right, so okay, right, I think almost everyone is here now. So all right, I believe all of you can see the screen. This chapter that we are going to start with is motion in a straight line. Okay, now in this chapter, and actually about 5 chapters that will follow, we are going to study about motion. All right, and you see, we all are surrounded by motion of different kind. If you would look around yourselves, you'd get so many examples of motion, right? For example, you see raindrops are falling, okay, from the sky. So that's rain, of course. It's motion of raindrops or water droplets. All right, wind, again motion, right? Blood is circulating inside your body, that is also motion, right? Okay, there are atoms inside your body. Atoms have electrons. Electrons move here and there in the atom, right? So that's motion. So actually, uh, you would say that the whole universe, everything that we see, everything that we see around ourselves, everything that we notice in the whole universe depends on motion. Okay, a quick check. Can you all see what I've written? Yes or no in the chat box? Can you all see what I've written? I will. Okay, you can see. Others, can you all see what I've written? Yeah, okay. Very good. Okay, fine. Thank you. Thank you so much. Right. So now, uh, let's begin, right? So let's begin with the first term, motion itself. So motion is actually nothing but as time passes, position of the object changes, right? That is called motion, right? If something does not change its position or place, then we say that object is not moving, right? So this is a very basic idea about what motion is. Okay. So whenever some object it changes its position as time passes, then we say motion is occurring or motion is happening or the object is in motion. Now this of course leads us to the next thing, position. You see, position is something position is something that is used to indicate the location or place, right? Okay, where the object is, location or place where the object is, right? So this is what is position. Now if you will think about motion and position carefully, uh, you will realize that both of these things, motion or position, such things actually depend on from where you are observing. That is, both of these depend on from where it is observed. What do I mean? Let's say this is a long straight road. Okay. And suppose this is you, right? And over here is your friend A. And let's say over here down the road is your friend B. Okay. So in such a case, we can we can say that if you're going to ask A, if we ask this question, okay, let's say you have some name, for example, let's call you XYZ. Okay, whatever your name is. Sorry. So if you ask A where is XYZ, okay, if you shoot this question at A, right, then A is going to say, well, XYZ is some distance away, let's say maybe 10 meter or something, okay, on my right side, for example, okay, according to this diagram, right, XYZ is 10 meter on my right side. Now on the other hand, if we are going to talk about B, if you ask B the same question, where is XYZ, then B would say, okay, XYZ is about maybe 3 meters on my left side. Okay. I would request all of you to please turn your mic off. Okay. Thank you so much. So now, like I said, where is XYZ has multiple answers, right? One person says 10 meter on my right, the other person says 3 meter on my left or something, right? Okay, if you're going to ask a flying bird, right, let's say you can talk with a flying bird, then that bird is going to say, well, let me do a dropping. This is where bird is. Okay, I've got someone asking, will you send board photos? I might, okay, but I might not send everything. It's better that you make notes. Okay, I will not send each and everything. I might only send the pages that contain the formula. Okay, so like I said, if there's a bird flying, then the bird might say, well, XYZ is 10 meter below me, right? So again, what I mean to say is where is XYZ has multiple answers, right? Okay, and all these answers, they change if you change who is observing, right? Or from where is that person observing, right? So because of this, it is, will you please scroll up? No, sorry, no. I would request all of you to please note things down as I write. Okay, this is a real classroom. You must note things down. I will send you this first screenshot, okay, for this once, but remember, never again. Okay, so everyone, please note things down. So we were talking about the question, where is XYZ, and like I said, you're getting multiple answers based on who is observing and from where is that person observing, right? Not only that, even motion. See, this was only about position. If we are going to talk about motion, if you are going to talk about motion of different objects, you're going to notice that even motion depends on from where you observe, right? I'm saying that motion depends on from where it is observed. Okay, so what do I mean by that? Let's take an example. Let's say this is a railway track, okay, and this is some train. All right, okay, don't go by the diagram. Drawing the diagram is important, that's it. And let's say next to this rail track there is a tree, okay. And now if you are in the train, let's say this is you sitting in the train, okay, and you're watching out, and as this train goes, let's say towards east, for example, obviously this side is west, right? So as your train moves towards east, okay, and you are in the train, right? This is you, and you observe the tree, right? If you observe the tree, right, then tree will appear to move towards west. Yes or no? Come on. Did you understand this? Yes or no? I want your answer. Okay, very good. Two participants raised hand. I'd like to remind everyone, suppose you have some question, you please type it in the chat box as good as you can, no problem, right? And I'll try to help you out. Okay. And suppose that doesn't work, then you have of course been given my number. You could maybe click a shot, click a photo, screenshot something, and send it to me, and we can discuss it, right? Okay. Chintan, you raised hand. I noticed that, but if you have some question, you could please type it. Okay. Yeah. So I was saying that if train moves east and you are observing from the train, the tree will appear to move towards west. But suppose that there was a little boy over here standing next to the tree. Okay, if you ask the boy, whether tree is moving or not, if you ask the boy whether the tree is moving or not, what do you think the boy will say? Yes or no? If you ask the boy, No, of course. Very good. See, all these things seem like common sense, isn't it? Right? Physics is actually easy, right? But you have to take it the right way. You should ask questions. Okay, you should ask questions and you should be curious. No, but he will say train was moving. Very good, Sahil. Okay, but I didn't ask you about train, right? We are talking about whether the tree was moving or not, right? So tree is not moving. Correct. Very good. So now, so now we have a question. Which is correct? Which is correct? Okay, just a minute. Let me finish writing this question. Which is correct? Is tree in motion? Is tree moving or not? What do you think? Yes or no? Is tree in motion? Yes or no? It is not in motion. Okay, some of you are saying yes, some of you are saying no. Train is in motion. Very good. Okay, train is in motion, not tree. All right. Right. Fine. Okay. Very good. Very good. Both are correct. Okay, Tapan says both are correct. Well, good answer that one. No, tree is not in motion as tree is stable. Okay, uh, that's called stationary. Stable, not stable. In physics, we call it stationary, right? Okay, so static, stationary, param, right? Same. Whenever something is not moving, the physics word for that not moving is stationary. All right. Okay, we say that it is stationary, not E, right? It's not stationary shop where you can buy pens and notebooks. It is stationary, that is not moving, right? Okay, so very good. So I've got a lot of answers. I'm actually very happy about that, right? So keep interacting. That makes this live class actually live, right? Because we all cannot see each other, meet each other physically. This is what we have to do with. So, anyways, coming back to this question, this one here, right? We are indirectly in motion. Train is moving. Okay, I'm getting more answers. Very good. Right. Now, I think it is time to tell you something very important. Do you know that Earth is revolving around the sun? Yes, no. How many of you know this? Yes or no? Earth revolves around the sun. Yes or no? Of course, yes, right? Come on. What stupid question am I asking? Right? Okay. So then I'm going to ask you, do you feel that it is moving? Do you feel it is moving? Do you feel the earth is moving? All right. Very good. I'm getting very good answers from you all. I'm very happy about that. No, we don't feel it. Correct. Well done, Saurabh. It seems like stationary. Correct. Ayush, that's right. Okay. Right. Fine. Fine. Very good. So all of you, my question to all of you is, you are not feeling it move, right? But you have been taught that Earth is revolving around sun. This is what your textbooks and your teachers have told you all along, right? But you are saying that we don't feel it moving, right? Mhm. So is it that the Earth is moving slow? What do you think? Is it that the Earth is moving very slow? That's why you don't feel it move? No, it's moving fast. All right. We are also moving. Very good. Very good. It doesn't move slow. It because of G force, no hard. Sorry, not the correct answer. No, Earth is not revolving slow. Very good. Earth is moving at great speed. Exactly. You all know the Earth is moving in space around the sun at a speed of this kilometer per second. In 1 second, 30 kilometers. Right? In 1 second, it is moving 30 kilometers. Right? Okay. Because we are also in motion. Very good. Well, see, this is a fact. From something, some vehicle or some object, from some vehicle moving at a constant speed, from some vehicle moving at constant speed, we cannot know that it is moving. It is impossible to do that. See, let me give you an example. If you have been because velocity of Earth and Earth is same, so it appears stationary. That's right. Correct. If you think of aeroplane, if you think of a plane, right? And I'm sure many of you would have been on a plane, right? Sorry, Ramdev, that is wrong answer. No, that's not true. Falak, no, that's not true. Okay. Mass has no role here, right? Mass is not important in this discussion, right? So let me continue. I was saying that if you have been on an aeroplane, you would have realized that once it is in air, once it is flying nicely, it doesn't seem to move, right? Once it is in air, it doesn't seem to move, right? Seems that it is just there, correct? Yes or no? Do you agree with me? If you have been on a plane, do you agree with me that while it is in air, unless there are some clouds and then the pilot will turn on the light and say there is turbulence and then everything will shake, right? Except for that, it just moves very smoothly, right? Nobody can know it is moving, right? So this is exactly how motion works. Yes, we feel it when there is takeoff. That is because of acceleration, right? So that's exactly what I'm saying. Whenever there is acceleration, we can feel it. But if it is moving with constant speed, read this sentence. If it is moving with constant speed, then we cannot know that it is moving, right? Okay. If you don't look outside, that is, suppose you look outside, right? If you look outside, obviously you can see that it is moving, right? You notice that it is moving, correct? So what I'm saying is, if there is a moving vehicle and the vehicle is moving at a constant speed, and if you don't look outside, then you cannot know that it is moving, right? No, Ayush, whether a vehicle appears to move or not, right? All that is, I mean, whether we feel something in our stomach or in our head, that is all because of acceleration, right? Okay, velocity is not important in that part. So coming to the point now, coming to the point. See, where are we going, right? I'm asking you some random questions about motion. Okay, Kashyap, I will answer that. Okay, fine. Yes, I can tell you. Yes, it's safe. Constant speed, uniform speed, safe. Right? Yeah. So where are we going with all these questions? Well, listen. It's that I asked you whether the tree is moving or not. Right? Okay. So boy says no, it's not moving. Very good about perspective. Well done, Falak. Well done. So it is that if you are watching the tree from the ground here, like the boy, then according to the boy, obviously tree is stationary, right? Okay, this is not Groot, right? Groot moves, this tree does not move. I was watching Guardians of Galaxy yesterday, so I got reminded of Groot. Okay, now, so what I'm saying is that if you watch the same tree from the train, then the tree appears to go towards the west side, right? So actually both are right. So the question is tree moving or not? If you ask boy, the boy will say no. But if you ask a person in the train, the person will say yes, right? So it's all about yes, both are correct. Very good. Now you all have really started understanding, I believe. It's that whether motion occurs or not, right? If you ask something, is motion occurring or not? Is motion happening? Is object moving? The answer to all these questions depends on who is observing, right? The answer to all these questions depends on who is observing and from where is that person observing. All right? Yes, reference point. Very good. I hope you all have understood the idea behind this discussion, right? So, if you want to talk about motion, if you want to talk about motion, then we must first specify who is observing and from where is that person observing, right? Okay. For example, you see right now I have my laptop over here kept in front of me, right? And you're seeing me through its camera, right? Okay. This laptop according to me is not moving because I can write on it and it's stationary. It just doesn't appear to be moving. But the fact is that my laptop or even your phone on which you might be watching or your laptop on which you are watching, right? All our phones and laptops, they're actually moving with the earth at 30 kilometer per second, right? Okay, so that is what is the importance of who is observing, right? And from where is that person observing, right? So that brings us to the next important definition: frame of reference. Okay, right, Vedant, you converted that, very good. Okay, frame of reference. So what is the frame of reference? Frame of reference means the situation, the situation or location from where the observer observes motion, right? So for example, if we will come back to this page, don't worry if you have not written, let me just go back a minute. uh, I'm saying that if you observe the tree, if you observe the tree from trace, then it appears to move. But you observe the tree from ground, then it appears to be stationary or not moving, right? So this is because these are two different frame of reference. For example, for you here, this is the frame of reference. Train is the frame of reference for you. But for boy, ground is the frame. Okay. So coming back to the definition, it is situation or location from where the observer observes motion. That is called frame of reference. All right. Okay. So typically, with every frame of reference, with every frame of reference, you have got three things. Okay. First one, reference point, which is generally taken as origin, right? Reference point, which is origin. Okay. Origin is from where we measure distances, right? This is from where distance is measured or position is measured. You could also say position, right? This is from where the distance is measured, right? Okay, correct. The second thing is direction or directions. That is, which direction is considered positive and which direction is considered negative. This is also called axis. Axis is the plural of axis, right? I'm sure you have learned in 10th that there is x-axis and there is y-axis, right? So plural is axes, right? So which direction you want to take x-axis, which direction you want to take y-axis, where do you want to take it positive and where you want to take negative. That is also specified. Okay. Uh, Let me go and let me give you an example of 1 and 2 before we go to 3. Okay. There is a third point, but before we go to that, let me give you an example of 1 and 2. Okay. So then we'll come back to this page again. Okay. So don't worry if you have not written it yet. So have a look. Suppose this is a long straight road. Okay, see, I'm going to give you an example about motion in straight line. Okay. So in this example, we are going to talk about somebody's home, right? Let's say this is someone's home, okay, on this straight road. Let's say this is east side, okay, of that house, and this is west side of that house. And this direction we are calling positive. So I'm saying east is the positive direction, and obviously west is the negative direction. All right. And I'm going to say that background noise is too much. Well, that's tough to believe. Something will be wrong with some connection. Okay, Sahil, there's not much we can do really. So again, let me say that if there's someone's house and this is east side, okay, which we are considering positive, and west, which we consider negative, right? And let's say you go to that house, right? You are looking for your friend, okay, right? You go to that house, and but your friend is not at his or her house, right? Instead, they are roaming around on the street. શું કરે હવે વેકેશન જેવું પડી ગયું છે નવરા છે ઘરેથી કાઢી મૂકે now so you have this is your friend over here, right? And let's say the friend is at a distance of 50 meter from the house. Then if I want to write about the position of your friend, okay, if I want to write about the position of the friend, then I would have to say that the position is, then I have to say that this position is 50 meter, okay, right? 50 meter from where? Obviously from house. So you see, you measured the distance from house. I'll repeat what I've said. The position of the friend is 50 meter from house. No, Vedant, we are not even talking about displacement right now. Okay, we talk about that in the next lecture. So position of friend is 50 meter from house. All right, but in which direction? Is the friend over here, or maybe in the sky floating above the house, or underground? Which direction? Towards east. Which direction? Yes, correct. So you see that this is plus 50. This is where the friend is, right? So position is plus 50 meter from the house, right? So I hope you realize that here we are taking this as the frame of reference, or this house or the ground as the frame of reference, and this is origin, and we are measuring this distance from origin, right? So 50 meter is the distance that is measured. 50 meter is the distance that is measured, and that distance is measured from origin, right? Okay, someone said west. Asif, I am not so sure what you mean. Friend is towards east, isn't it? Okay, not towards west, right? So position of friend is plus 50 meter from the house. right? So plus indicates east direction again. So what I mean to say is here we have defined, or we have taken that positive direction is east. So automatically negative is west. So this is what I meant by the 2 points, right? One is reference point. Okay. Okay, you are telling about origin. Yeah, correct. So that's right. So now what this means is we have defined directions and we have defined origin. Let's say instead of that, right, we don't want to measure, we don't like this person's house. Okay, so instead of that we want to measure the position of that friend from this house, let's say over here. All right, fine, from over here. Okay, and this house is at distance 20 meter from this house. All right, so now if I take this as origin, if I take this as origin, can you tell me now what is the new position, or what will be the position of friend for this kind of origin? Can you all tell me what is the position of the friend for this origin? Okay, and okay, very good, very good. I'm getting so many right answers. Well done, all of you. See, it's not away. You should not write away 20 meter from first home. Well, see, Dhruvanshi, that's not going to work. See, let me explain that. Hard, no, not true, not the correct answer. See, I want all of you to understand that we measure position using some origin, right? Okay. So where did I tell you we are taking origin? We're taking this house as the origin. Okay, we are taking this house as the origin. So from this house, the position of the friend is 70 meter, right? Because I'm sure all of you understand that this distance is 70 meter. Okay, someone raised hand. Can you please type your question if you have any? Okay, if you have any question you can please type it, no problem. 100 meter towards the west. How is it 100, Kashyap? How is it 100? Huh. Okay, continuing explanation. We are measuring distance from origin, right? We are measuring the distance from origin. So from here all the way it is 20 plus 50, that is 70, right? But towards the right hand side means towards the positive side or towards the east side. So if someone would ask you what's the origin of the friend, the correct answer is plus 70 meter. The correct answer is plus 70 meter, or you could say 70 meter east. Okay, either way. All right. Hard, minus 50 meter? How? No, no way. You have to measure distance from origin, right? And you have to measure position of this friend from origin. Compared to this origin, this person is 70 meter on the right hand side. Okay. So 70 meter on the right hand side means 70 meter on the plus side, or 70 meter on the east side. I hope that it is clear to all of you now, right? Some of you made some simple mistakes, but I hope now everything is okay. All right, fine. Now, so that is what is about position. And you can see if you change origin, let me write this again. If you change origin, if you observe taking different origin, then obviously position will be different, right? If you change the origin, position will be different. For example, in first case it was plus 50, but in second case it was 70, plus 70 meter, right? So like this it would change, right? So that is why we go back to what we were writing here. reference point is important, directions are also important. That is, which direction are you saying is positive, right? Like, I said here right side is east and we considered east to be positive, right? But someone else might not like east, they might like west, and they might say, sir, west is positive and I'm going to take east is negative. No problem, no problem. Okay, that is valid. Where we put the positive direction and negative direction, this is both, right? Over here what we are writing, all this is choice of observer, right? The observer can choose, observer can decide, right, what the observer wants to do, right? If I decide, if I decide that I want to take origin or zero here, right, then I have to measure the distance from this zero. If I decide that I want to take it here, I'll take it over here, no problem. But yes, same observer in same situation should not change it. Once you decide it is here and you want to study how something is moving, then you don't change it, right? Okay, so that is about frame of that is about these 2 points of reference point and directions. Now we go to third one. Obviously if you want to study motion, time must pass, right? Because if you cannot keep track of time, if you cannot measure time, you will not be able to find out so many things like velocity, speed, etc., etc., right? So that's why there has to be a clock, right? There has to be a clock with the observer, and again the observer can choose his or her own time. What do I mean? Let's say that I'm going to drop a ball. Let's say that I'm going to drop a ball. Okay. And I want to find out in how much time it will hit the ground. Okay. I want to find the time in which it will hit the ground. Okay. Right. So you see, we can do it in many different ways, right? With different kinds of clocks. So let's take an example. Okay, suppose that one person observes this and that observer takes a stopwatch, right? I'm sure you have seen that on a stopwatch, if you click once, it will start from 0000, right? That is, and point 0, right? Because stopwatch can measure milliseconds also, right? Something in milliseconds, right? Okay, so what I mean to say is it would measure a very small time, right? On the other hand, some other person might use a phone's watch, okay, or phone's clock rather, actually, right? Someone might use a phone's clock, right? I'm sure all of you have seen that there's a clock on the phone, right? So if you would use that, okay, then it's possible that right now if you are doing this experiment, it might be showing 8:54:00, right? That's what it is showing in my phone right now. So I'm writing 8:54:00 a.m. but this stopwatch shows 0, and then we allow it to drop. Okay, suppose it takes 1 second, then here it will become 01 finally when it stops, right? Okay, so this is start and this is stop, right? 0000, like that. And here it will be 8:54:01 a.m. So now what I mean to say is, out of these two, out of these two, the observer, obviously there are the observer can actually choose any of these. Both are meaning the same. The only difference is here the observer takes this time, 0 time, as starting time, but here the observer takes 8:54:00 a.m. as starting time, right? Okay, but I hope you realize that in both it takes 1 second, correct? So at what time observer starts to observe, it really depends on the observer again. Let me repeat. at what time observer starts to observe, it really depends on the observer. But generally, what we do is we generally take the starting time. This is general, not a rule. Okay, right? Not a rule. This is what we normally do. We take the starting time as t equal to 0, right? That is, whenever we start observing, right? Whenever we start observing, at that starting time, we take t equal to 0, right? This is what we generally do. Okay, it's not compulsory. Even if you measure it like this, like I've said, starting time is not 0. It is 8:54. No problem, right? Does not matter. Okay, right? So finally, what I've said is that if you want to study motion, right? Okay, then the observer should be there, right? Observer will be observing the motion. The situation or the location from where the observer observes is called frame of reference. And when someone is observing motion, that observer will have to choose three things. Which three things? The reference point, that is origin, okay, from where the distance is measured. And then the observer will also have to choose a direction in which the person will say positive and negative, like we did east positive and opposite west negative, right? Okay, so like that. And ultimately, if you want to measure some motion, finally you need to have a clock, right? You want to get if you want to know about quantities like speed and velocity and all that, acceleration, etc., right? So then you would need a clock, right? And even in clock, the observer can actually choose any time to start with, but normally or generally we take the starting of observation as t equal to 0. T for time and equal to 0 means that's where we are starting. Okay, right? So with that, we are going to stop this class, right? I think I will just give you one question to think about. Okay, and we will discuss the answers tomorrow. Okay, not now, right? So the question is here. Simple question. Okay, it will only take 1 minute for you to solve. Let me tell you that. Suppose that this is a tree on a long straight road. All right, and let's say there are two persons, right? Fine. For example, this is, let's say, Ramesh. Okay, and let's say this is Suresh. Okay, probably these are the two guys that appear in the 5-star ad. Okay, and now suppose Ramesh is at a distance of 30 meter from the tree on this side, but Suresh is at a distance of let's say 40 meter or on the other side. Okay, fine. Now, if we take this west direction as positive and east direction as negative, okay, and origin is at the tree, all right, origin is at the tree, 0, then you have to tell me what is the position of both of these. Okay, that is your question. What is the position of both of these? You have to answer me by tomorrow. Okay, no problem. Don't bother answering right now. Clear? What is the position of both of these? All right, so I hope everyone understood that, right? Hopefully you will join the class tomorrow, right? Goodbye.